Hello Calculus student, this video is for chapter 5.4, part 2. Continue with net change theorem. So we'll do more work problem today. Just a quick review. So if I want to find net change of a function, primarily I want to do fb minus f of a, not just fb, not just fa, but the difference. We call it net change. Then it's actually the integral of the ray of the function, the same function, dx from a to b. So it's very useful. It's from the second fundamental theorem of calculus part 2. Okay, so you can say net change is the integral of ray. And last time we were doing an example on total displacement. We want to know how much a particle change position if we know the velocity. So without solving for s of t, we can actually just do 0, 3, and then we know the displacement is negative 3 over 2. Now for total distance travel, we say we would need to do absolute value because distance are absolute value. And we have written it down as like this. And we didn't completely do the work it out. So it's 41 over 6. What you can do is from 0 to 5 over 3 is a negative velocity. So you would make it as a change into positive by taking absolute value. So that means negative of v of t from 0, 5 over 3. But from 5 over 3 to 3, the velocity is positive. So we just do a like this. And then the way I do it is, I don't have enough space to do that, but I put in decimal. You can see that this is a negative v and this is a v. From 0 to 5 over 3, I put negative v is 25 over 6. And from 5 over 3 to 3 time, it is positive, so it's 8 over 3, and if you add them together, it's 41 over 6. So that's the answer. So let's move on to more examples. So all of them involve finding net change, but you have to look for the ray. So if you know the ray, you can find net change. Okay. So this example is water flowing into a restaurant or a tank. Oh, it's a tank. And then the rate of change is 500 minus 5t liter per minute. So as time goes on, the rate decreases. Find the amount of water that flow out of the tank, or the water flow from, during the first 10 minutes. So these are minutes, and we're talking about minutes. So we just want to know how much it flow out. So the net flow would be from A to B, which is from 0 to 18. Do I have the rate? I have the rate. 500 minus 5t dt. This is a very easy thing, integral to do. So it's 500t minus 5 over 2 t squared, because t is t squared over 2. And we do from 0 to 18. So that means 500 times 18 minus 5 over 2 times 18 squared. And you plug it in the formula that is, do I have it? Oh, I didn't do it. So be 500 times 18 minus 18 squared times 5 over 2. So it's 8190. 8190 liter. Is it the correct answer? We can use decimal to check. The second is rate of change. Again, a rate of change of population of the insect. It's like that. Find the net change. Net change. So we know net change is the integral of the rate. Net change in population. So just do that first. Integral of the rate from after 15 days, from 0 to 15. And then we just put the rate in negative 3t squared plus 4t plus 1 dt. Okay, so that would be negative 3 to the 3 cubed over 3 plus 4t squared over 2 plus, oh, this is a 2, plus t, and then from 0 to 15. So that would be negative 15 cubed plus, this is a 2. 2 times 15 square plus 15. So there is a negative. It seems like a negative number because I see negative t cubed is really big. Really, 15 to the power 3 times negative 1 plus 2 times 15 square. And then plus 15, but I think these are negative, negative 2910. Okay, so but the initial was 10 insect. Well, that means there's no more insect, right? So the number of insect would be the net is net decreasing that much. And if the initial is 10 insects, so the final would be population at 15 would just be 0 because you have 10 minus 2910. I think this is a bad problem. Because it decreased so much that it wipe it out. And then the third one is a total cost and marginal cost. So we have a marginal cost C prime and we have a total cost C. Someone write integral 50, 60 C prime of X. What does it mean? Well, by Nernst theorem, that means cos at 60 minus cos at 50. Right? This is the rate and this is the actual function. That means the change of cos from x equal to 50, if you're producing 50 to x equal to 60. So how much additional cost it is to produce 10 more when you are 50. The next example is acceleration. If I have acceleration is negative 9.8 meter, what is the net change in velocity? So do I have the rate of change of velocity? Oh, rate of change of velocity is 8 of t. So net change in velocity would equal to from t to 5, right? From 0 to 5, the rate is negative 9.8 dt. So this is really easy to do. It's negative 9.8 t from 0 to 5. So that means 9.8 times 5, right? 0. No, negative 9.8 times 5 minus 0. So it changed by negative 9.8 times 5. So negative 49. So the velocity changed by negative 49 meter per second. If initially it's 30, what is the velocity at t equal to 5? So the final one is equal to initial at the change. So it would be falling down, negative 49. Oh, negative 19. 19 meter per second. So you can see that you don't even calculate what the velocity is, but you know what the final one is. That's the power of net change theorem. You actually do not need a function if you only want the difference.